Okay, good morning class. So at this point we're looking at analytical geometry. Yesterday we have marked our cycle test and the class test you have written. So your homework was exercise 11.1, 2 and 3. Okay, any problems with 11.2? What did you have to do out of 11.2? Sorry? You have to do every alternate sum here. Right. So, but we completed it. The rest. Any problems with 11.2 number 1? Any problems with 11.2 number 1? Number 2? Number 3? Any problems with number 3? No problems here. That's how it comes in the exam. No? So now number 3, so since you know it, it's good. Number 4, we spoke about that already. Number 5. Number 6, we did that. Spoke about that. Number 7, we spoke about. Number 8, we spoke about that as well. So any issues there? No. Then we went on to the midpoint of a line segment. Not so. We said for the midpoint of a line segment, what's the formula? x1 plus x2 over 2 is equal to y1 plus y2 over 2. Not so. We spoke about how they got that to that value, or that formula. Then you had to do 11.3. Any issues with number 1? A. 11.3. And this on page 229. Which page is this on? 249. 251. Okay, thank you. Yes? A and D. Did I ask you to do all of this here? Huh? Yes, no problem. So let's look at A. So it says draw a rough sketch in each case. Okay, so if it, I'm sure you guys know how to do this. No? So A is going to be x1 plus x2 over 2, y1 plus y2 over 2. So they ask you to calculate the midpoint. So if this is x1, that would be y1, x2 and y2. Okay. So it's going to be 4 plus negative 1 over 2 and negative 1 plus 3 over 2. Okay. So 4 minus 1 is 3 over 2 and 2 over 2 is 1. That's your midpoint. Who asked this question? Okay. You only said in your formula. Okay. So is that you only made the mistake once, or you threw out the whole thing? I made the mistake once and I tried to do that. So you said wrote the formula down once. Okay. It's fine. I don't think you'll get it wrong from here because you've written down the formula a few times. Okay. It was A. Let's look at B as D. The midpoint is going to be x1 plus x2 over 2, y1 plus y2 over 2. Okay, so if this again is x1, y1, x2, y2. So that would simply be A plus minus A over 2 and B plus 2B over 2. That cancels, leave it 0 over 2, which is 0, and 3 over 2B is your y value. Okay, or 3B over 2 is the same. Where did you go wrong here, Michael? Who asked this question? Yes? You just want to talk to me a little? No? Okay. Yeah, you never talk to me, but it's fine. Right, but you don't know how to do it. Good. Let's go with the next one. 2. Any issues here? A, B? Nothing? No problem, number 2. Okay. Was that the end of the exercise? Let's just check here. You grade 10. You did exercise 11.3, you said, no? Alright, so let's just check here what still needed to be done. So we did example 1 and example 2. This is now example 3 on page 250. Okay, so we're looking at example 3 on page 250. We are told ABCD is a parallelogram with vertices A, which is 2 and 3, B, which is 5 and negative 7 and negative 5, C, which is 3 and negative 11, and D, which is XD and YD. Okay. The question says calculate the coordinates of D. So, what are the properties of a parallelogram? What's the properties of a parallelogram? 2 pairs of opposite sides are equal, yes? 2 pairs of opposite sides are parallel, yes? Opposite angles are equal, yes? The diagonals bisect. What does that mean? Trisect. Huh? Cut each other in? Oh. So, if you say that the angles bisect each other, that means to say that the angles cut each other in half. Which means to say that it's actually, if AB is diagonal is cutting the diagonal of B, what you notice is that M is going to be the midpoint of AC, and M is also the midpoint of DB. You all agree with that? No? So it's sharing a midpoint. So whenever the diagonals are bisecting each other, the midpoints are the same. Does that make sense? No. So can I calculate M using D, the coordinates D and B? No, we're shorting D. Not so. Can we calculate the coordinates of M using A and C? Yes. So how are we going to work out M? So it will be x1 plus x2 over 2, y1 plus y2 over 2. Why this formula? Because M is the midpoint. You understand, people? And this is the midpoint of A, which is 2 and 3, and C, which is 3 and negative 11. Right, work out M quickly. Alright, so that gives us, if this is x1, y1, x2, y2. Not so. So M, x1 is 2 plus 3 over 2, and 3 plus negative 11 over 2. So M will be 5 over 2 and 4. Not so? Negative 4. No problem. You want the negative? No problem. It's right. You're absolutely correct. So you got 5 over 2 and negative 4. So how are we going to calculate D now? This is now the end point given you have the midpoint. Can you see that, people? So now you're going to work in the reverse. Okay? So do the reverse calculation for D now. Are you guys finished? So busy, okay? I'll give you a chance. Okay, so we got D. I'm going to draw it here. D is the end point, so it's XD, YD. M is of course the midpoint, which is that point there. And we have B, which is 7 and negative 5. You all agree with that? And those lengths are equal. So what we say, XD plus 7 over 2 is equal to the x midpoint, not so, 5 over 2. And then you got yd plus negative 5 over 2 is equal to negative 4. Okay, you all agree with that? No? So what do we do now? Cross multiply. So 2 times xd is 2xd plus 14 equals 10. Take 14 over the equal sign, so twice xd equals negative 4. Divided by 2, so xd is equal to negative 2. You will agree with that? By the sounds of it, you guys didn't get that, so I'll give you a chance to do that part of the calculation. Okay, so what do we get on this side? Again, we cross multiply, naturally over 1. It's probably behind the calculator at this point. So you got yd minus 5 is equal to negative 8. So yd is equal to negative 8 plus 5, which is negative 3. So therefore, the question was the coordinates of d. So d is going to be negative 4 and negative 3. Sorry, negative 2 and negative 3. People, you guys understand? Let's carry on with our lives. Alright, so for homework I want you guys to do. You did 1 and 2 now? Yes. You're going to conclude this this exercise, okay? So you're going to do number 3 to number 7. Please do it so that I can see what are the issues pertaining this, okay? So that later on, if learners have a problem with this, because what happens is learners tend to have the same problems that previous students had. Okay, does it make sense? So there's common problems or common mistakes that learners make. Okay. So if you guys do it and we do this properly, then the others will benefit from it later on. Okay. At the same time, you people will benefit from it if you do your homework also. Okay. Okay, we'll write another class test soon. I know that was coming. Namutali? Wasn't? Yeah, you all hurting my feelings. That girl don't want to talk to me. You don't want to write a class test. How much I feel? Huh? I'll cry later at home. Huh? It's fine. It's okay. Right, so if you have any issues, so let me know tomorrow during our maths lesson. We'll wrap these questions up, okay? Nice. We just write here, it was exercise. This is exercise 11.3. Page 251. Right. So that's that. So let's carry on with our lives. The gradient of a line. Next heading. The gradient of a line. People, have you heard about this before? Yes. Oh my word. You have learnt of it before. You have heard of it before. When we drew straight line graphs. Not O. It's a gradient. It's a G. Or M. What's wrong with you? It's easy, no? When somebody asks you something, it's easy to say, no. No, because then you think now it will be taught from the beginning again. Crazy. And it's the same thing when you guys go for tuition and stuff like that. No, the teacher never explained it like this. No? Or you say, no, the teacher did it like this and then you make a mistake. No? Yes, but then you understood it wrong. No? Yes. I know already. We work with tons of you guys. Or guys like you. Or girls, no? You should say girls. Right, people, grading of a line. This is on page 253. Let's just check here. Delta y over delta x. Delta x over delta y. That's a mistake here. Just checking your text. Hello. Good and yourself? Ubadin, yes. Yes, I'm just in a class, man. You must phone me back after 3. Okay, thank you. Who gave you so much work? Me. Do I give you a lot of work? I give you a lot of work and you people don't do it. That's the thing. Because I chose in your class test the results. Yeah? From the class test result I can see you people not working. And you must remember, that exactly those class tests that I give you people was either in last year or previous year's exam papers. So let that sink in. If I was that student actually writing this paper, where would that have put me? Keep on asking yourself that question. And she said, you're making jokes, but at the end of the day, my girl, how we build a nation like this? How do we build a nation? Right, we're on page 253. And it's nice, man, if you say, the people say, oh, you're doing maths? Yes, we're doing maths. Nice. But what's the use you're doing maths and you're not passing it? You know what I'm saying? Then it's better for you to get the A for maths later. But if I would have a choice, I would rather get a pass mark in maths than any mark in maths later. Okay, because the problem solving you are working on at least. Okay, it's more abstract than maths lit, which is how can I say, real life situations where you're working with not bank records, what do you call that? Bank statements and budgets and stuff like it. And you want to buy tiles for your house and all of those things. No? And when the date in with Christmas is, You guys know when Christmas is? Yes, the 25th. Questions like that. No? And most courses at university needs you to do maths. Okay, so right, so we are looking at the gradient of a line. We are on page 253. We're reading through this here. The slope or gradient m. So the mathematical notation or the mathematical symbol for the gradient is the italic m. Of a line is a measure of its steepness. Okay. Now, when you were in grade 9, we said the m means what? M denotes slope, gradient, or inclination line. Angle of, line of inclination. Okay. Then we are told we define the gradient or slope m of a line by m, which is your vertical change and your horizontal change, which is delta y over delta x. This I need you to write down. Okay, so you got the heading there. So m, which is your change in y over change in x. Delta y over delta x. So here we are given in the note. Other words used for steepness are incline. Remember I said inclination? Incline is the same thing. So where do we use the word incline? We use it when we talk about this, the roads or ramp. The ramp as an incline. Okay? And a pitch used for roofs. Okay? So you know the roofs that has a pitch as an incline. Okay. The notation delta y over delta x is read the change in y divided by the corresponding change in x. Alright. So here, if P is xp and yp and q is xq and yq are points in the Cartesian plane, then the gradient of the line joining PQ is m subscript PQ is delta y over delta x. This is a mistake. Yeah? So correct that in your textbooks, or was it corrected? Sorry? Wasn't corrected. Okay, that's a mistake from the person who typed here, but no problem. It's okay. Alright, we make more mistakes than them, no? Yes. So note that the subscript in the numerator and denominator must correspond. So here, what do you notice? You got xq minus yp, over xq minus xp. Can you see that? So if q is first in the numerator, q must be first in the denominator. Likewise, yp minus yq is equal to, yp minus yq over xp minus xq. Can you see p was first in the numerator, so xp must be first in your denominator. You guys understand? Alright. Now I need to make this note that is right. We spoke about that there. Parallel lines. Next, the subheading there, parallel lines. We define any two non-vertical lines to be parallel if the gradients are equal. Then I need you to say then that line 1 and line 2 are parallel if they have the same gradients. M1 is equal to M2 and vice versa. L1 is parallel to L2 if and only if M1 is equal to M2. That's what I need you to write down. I think that's too small for you guys, no? Can you all see? Alright. So make that note. I'm going to pause the video at this point. Alright, so at this point you have completed the note. Those are lines of parallel. So when lines are parallel, what do we know? Gradients are equal. If gradients are equal, we know that the lines are parallel. Okay. And next note I need you to make, if lines are perpendicular. That's your next subheading, if lines are perpendicular. And we'll read the note now. It says, in each case A to F, in each case A to F, line L1 and L2 are perpendicular. What does perpendicular mean? It's at 90 degrees. Not so. The angles are at 90, or the line stands at 90 degrees to each other. Okay. Read off the gradient of each pair of lines and make a conjecture. Now, conjecture is your findings basically. Okay. Oh, sorry. I froze the board but didn't unfreeze it. About the relationship between the gradients of perpendicular line that are not parallel to the axis. So if you take this into account, I'll just make this a bit bigger. I think the what's the name is bad there. Okay, so if I take L1, the gradient of the first line into account, what is the gradient of this? The rise, and the rise is 2 and the run is 3. Not so. If I look at the gradient 2, the second gradient, what's your rise here? The first is gradient positive or negative? Negative, because that's lying to the left. Not so. As you can see here, the line is lying to the left and the line is decreasing. So if it's lying to the left or decreasing, the gradient is negative. What is your rise here? 3. And your run is 2. Right, we'll come now back to that. We're going to talk about the conjecture or the relationship you notice. Okay. This is line 1, so gradient 1. In B, what is your gradient in that case? Is it positive or negative? It is negative. Yes. What's your rise here? That is your. You take your gradient from here. So your rise is 2 over run is 4, which is negative half. Not so. So let's look at the gradient 2. So the gradient 2 is coming from line 2. So what's your rise here? This is going to form your triangle there. What's your rise here? 2. And your run? 1. Gradient positive or negative? Positive. So that gives you 2. We're coming back to that now. Okay. And then lastly, are you seeing it already? What's the relationship that's happening between this? Not, it's reciprocal. Yes, it's reciprocal, absolutely. Nice. You multiply, no, it's not reciprocal. The reciprocal says you multiply two numbers, the answer will be 1. Not so. This was a reciprocal. What's the reciprocal of 2? 2 over 1. 1 over 2, sorry. So that is 2 over 1, will give you 1 over 2. The reciprocal is when you multiply two numbers, it's going to give you an answer of 1. But what you notice here, if you multiply these two numbers, gradient 1 times gradient 2, what do you notice, what do you get? So it's 2 over 3 multiplied by negative 3 over 2. What do you get an answer? Negative 1. Did you see that? Let's look here, gradient 1 times gradient 2 is equal to negative half times 2, which is negative 1. Can you see that, people? So let's look here, the gradient 1, what's my rise here? The gradient positive or negative? Negative is lying to the left. Okay? Your rise here, 3, and your run is 3, which is negative 1. Gradient 2, the positive gradient, as you can see, is lying to the right. Your rise is 2 over 2, which is 1. Again, gradient 1 times gradient 2 was minus 1. So what can we say? If lines are perpendicular, then gradient 1 times the gradient 2 is equal to negative 1. That's your next note that you need to make under the heading if lines are perpendicular. All right, and there we just made the conjecture or findings we had there. Okay, so that is in order there. That's exactly what they explained to us here. They told us it was from A to F, it's A to C. Or did I miss anything here? To check the textbook? Is it only A to C? Yeah, it's A to C. So they made a mistake there as well. Conjecture. If L1 is equal to A over B, where A and B is not equal to 0, then the gradient of L2 perpendicular to L2 is equal to minus B over A. Okay, that's exactly what we just said now. Okay, that if you multiply the two gradients, the answer must be -1. And you guys must write that note down. Okay, note, if L1 is a horizontal line and L2 is a vertical line, then those lines are also perpendicular. Not so? Because we already know that your x-axis always stands 90 degrees to your y-axis. Not so? We know that already. Okay? So a vertical line is always parallel to the x-axis. And a horizontal line is always parallel to the... Sorry. The horizontal line is always parallel to your x-axis. And your vertical line is always parallel to your y-axis. Not so? So in that case, your lines will also be perpendicularly. Okay? Because the horizontal line's gradient is 0 and your vertical line's gradient is undefined. Not infinity, undefined. Okay. So those two graphs again, or those two lines, will be perpendicular again. Okay, but that doesn't conform to this, to that formula. You understand? Because if you multiply an undefined number by a 0, you don't get -1. Okay, but this is now exception to the rule. Okay. Again, so make a note there. If L1 is a horizontal line, if L1 is a horizontal line, L2 is a vertical line, then they are perpendicular. Then the lines are perpendicular. Okay. Alright, so now we're looking at the example on page 253. Let me just check if that is correct. Otherwise you can't do your homework because I did the wrong page's example, or I wrote the wrong page number down, so you couldn't have done no homework. There's 255. Page 255. Okay. So may I do that reference, example 1 on page 255. We are told that A, B, C, D. So A, B, C, D is a quadrilateral with AC, with diagonals AC and BD. Okay. The question says, prove that. So if they tell us prove that, what does that mean? If they say prove that, what does that mean? That AB is in fact equal to or parallel to DC. Okay. That is the case. We just need to show it. Okay. If you get a proof that or show that question, you can't use what they ask you to prove in the proof. You understand? Does it make sense? So, say for argument's sake they ask you to prove that this is a remote. No? You all know it's a remote, no? Then to give a description of this remote, I can't say it is a remote. Okay, so we haven't been proven. You understand? And so on and so on. So, again, coming back to A, we must prove that AB is parallel to DC. So we can't use that fact in our proof. We must end off with that fact. You guys understand? So from the notes we wrote today, what did we know? What did we say about if lines are parallel? The gradients are equal. So what I want you guys now to do is to work out the gradient. This is now A. We're going to work out the gradient of AB by saying y2 minus y1 over x2 minus x1. For A, which is 3 and minus 1. B, which is 8 and 2. Right, you're going to do that for me quickly. Thereafter, you then work out the gradient of DC. Same story. Okay, you see, I'm not saying anything of the lines are parallel. You'll see me in the conclusion, concluding that it is parallel. Okay? Let's see how I do that. So I'll pause the video again at this point. So what do we have? Is this x1, y1? x2, y2. Always write it so on the side, so that you don't make a mistake, but the examiner sees which point you are using clearly. So y2 is 4 minus 1. Not so? Over 8 minus 3. That gives us an answer of 5 over 5, which is 1. Not so? Now we do the same for DC. So D, which is 2 and 6. And C, which is 7 and 11. Okay. So y2 minus y1 over x2 minus x1, if that's x1, y1, x2, y2. Again, if you made that x2, then this should be y2, x1 and y1. Does it make sense? Right. Yeah. So we go y2, which is 11 minus 6 over 7 minus 2. 11 minus 6 is 5. 7 minus 2 is 5. 11 minus 6. Yeah. So it's 5 over 5, which is 1. Not so? So what do you notice? They're the same. Same grade. So we conclude as follows. We state the obvious. We say since the gradient of AB is equal to the gradient of DC, which is equal to 1. Both gradients are the same. Therefore, AB is parallel to DC. AB is parallel to DC. Okay, any confusion here? Nobody that's confused at this point. So I'm going to put this in here. I'm going to add something else afterwards to this, okay? Alright, let's look at B. In B, they ask you to prove that AC is perpendicular to the readings. So AC is perpendicular to DB. Okay. So if lines are perpendicular, what do we know? The product of the two gradients is -1. Yes. So to prove that these lines are perpendicular, we now prove that the products of the two gradients is -1. You understand? So if they tell us it is perpendicular, we know that the product of the two gradients is -1. If they ask us to prove that it is perpendicular, you show that the products of the two gradients is -1. Make sense? Right. So let's go with B. So what do you think we're going to do here? We're going to work out the gradient of AC and the gradient of DB. So do that quickly. You don't have to write the formula down again. Normally we just write the formula down once in a question. Okay? In the question paper. So A, which is 3 and 1. C, 7 and 11. B, 2 and 5. B, Alright, let's just wrap this up quickly. So if this is x1, y1, x2, y2. So it's going to be 11 minus 1 over 7 minus 3. 11 plus 1 is 12 over 4, which is 3. Okay? The gradient of dB, again x1, y1, x2, y2. So it will be 4 minus 5 over 8 minus 2. So it's negative 1 over 4 minus 5 and 8 minus 2. 6. Okay, I think I wrote down something wrong. D is 2 and 6. This is my mistake. 2 and 6. I wrote 5 for some reason. 2 and 6 and 8 and 4. So this will be a 6 here. So that would be negative 2 over 6, which is negative a third. Not so. So what do you notice now? Below that you write, since the gradient of AC times the gradient of dB equals 3. Okay, we just put it below here. It looks like this is too much on top of each other there. We say since the gradient of AC, which is 3 times the gradient of negative a third, is equal to negative 1. Therefore, AC is perpendicular to dB. And that's how you end of this. This counts 1 mark. No? We're wrapping that up properly. Okay. So, just coming back to this here quickly. What type of shape is this? Can it be a kite? The opposite sides are parallel. How can it be a kite? A rhombus. How can you say it's a rhombus? What's the properties of a rhombus? All the sides are equal. Look at the rhombus. The least it could be, you're right, a rhombus. That's the least it could be. Why? Because the diagonals are perpendicular in 3. A rhombus, a square, and a
Rachel Turwa, please report to the office.
The opposite sides are parallel.
Please report to the office.
It can't be a square because we have to prove more than what we have. So the least it could be is a rhombus. For homework, I want you guys to do exercise 11.4. You do for me number 1, first column. Or you do number 1 and number 2. And 3. 1, 2 and 3 for tomorrow. People, enjoy the rest of your day. Good morning, class. Bye. Enjoy the rest of your day. Why you throw yourself on the floor? Are you okay?
So I'm gonna come second by 5, 4.8 to the minus.
Inshallah.